thank you all for kind of putting yourselves out there and talking about what, unfortunately, these are controversial topics. I don't really know how they became controversial, but the idea of registries is controversial because of our current government that's saying that we need to collect information from families without their consent and use them. And I'm not even talking about the way they're being used, or how they're being analyzed. And then Dr. Spiro, for whatever reason, subtyping has become controversial because we just in the last DSM-5 decided to put everybody on the same spectrum, and now we're saying, okay, well, within that spectrum there are differences, even though I think we can all agree that not all people with autism are the same. And Dr. Sanders, this idea of genetic medicines can be controversial because not everyone has one of these rare variants or one of these de novo variants. So if it helps 20% of the people, great, but it's not, a sustainable kind of solution for everyone with autism. So my question is, how would you address those controversies? I mean, how would you respond to registries can be really, really helpful, and they can be incredibly useful for understanding etiology and improving precision medicine, but they can also be misused. And Dr. Spiro, how do you reconcile the autism spectrum with these subtypes of autism? And Dr. Sanders, what would you say to people who think, well, this is only going to help 20% of people with autism? We can start with Dr. Shendell.
Okay. Is this on?
Yeah.
Is that on? Okay. I give a lot of thought to that, actually. How would we take something that the NIH has announced and what they might want to do with ADSI? I think you might also want to develop some sort of independent panel, independent advisory group or watchdog group that would govern, that would set into place the parameters on which information can be shared and can be analyzed, and under what security conditions and under what safeguards for the information, with the consensus by the users and the donators of that information. I think you have to develop a system of trust. There has to be parameters of trust that individuals will say, okay, it's okay. You can use my information, but ensure that I won't be violated in the future, me or my family. I don't really know can't think of any other way to do it without establishing that system, that systemic system of trust, which is what they've had in Denmark, for example, but they started it many, many years ago, before computers even. And so there wasn't this threat of data mining when they first established the system. So the system of trust is in place. And even today, they trust that that information is not going to be misused because there's never been a breach. And I think that that's a lesson to establish the trust very early on with the parameters around safeguarding information and participants voicing their concerns and being addressed in the framework for sharing. But there is no magic answer.
So I'm not really a historian of science with any credentials, but the one thing I can say with some confidence is the decision in the DSM-5 to put everything back into one category was most definitely not because of an acknowledgement, well, it really is one thing. It was for other reasons having to do with reproducibility of different diagnoses, and some of the early science, Simon's projects actually played some kind of role in that it was very clinician dependent whether someone got a particular diagnosis of something like Asperger's or not. So it wasn't a statement like, oh yeah, actually it really is one thing. I actually think, with the exception of the question that a gentleman over here asked about access to services being dependent on a diagnosis of autism, it really kind of strikes me as uncontroversial that the spectrum is really, as we currently define it, is made up of some distinct biological processes. I really don't even think that's controversial. Of course, access to service is critical, and issues of identity and things that are very complicated having to do with labels. But the fact that we need to take this bowl of fruit and figure out, for all different reasons, for research and for families, I think it's just critical that we need to do it. How we go about do it, I think, is very much an emerging topic. But I don't think that's controversial.
And then, so my question was, how do you expand genetic medicine so it's not just a few anecdotes or 15%? And so I think the first thing is to recognize the key question is what's possible. Even, it doesn't matter which disorder it is, what method it is, whether it's gene therapy or CRISPR or ASO. I think the key question is what can be improved at what age? Now that probably will vary according to different subtypes of autism when we know them. But just knowing that it was possible, I think that's the first really important part. I think the second part is genetic medicines are a little bit like mobile phones. You know, we're at the car phone stage. They are very expensive, very rare, unfortunately tending to go towards the privileged few. But what we need to do is to build the world where they become like the mobile phone in every single one of our pockets, where it's not a sort of anecdote costing millions, it's just another medicine which is cost effective. And I estimate roughly a 10-fold reduction in the cost of an ASO would get to the stage where it's sustainable in the population and the health service. And then I think the last bit to that is that anyone working within autism needs to be trained holistically. You need to think about the entire process from causal factors, biology, all the way to meeting families and affected individuals. And going back to the ASF, one of the key bits is actually trying to highlight that holistic training. I think that's critical to making sure that whether you're working with the registry, subtypes, or genetic medicines, that you're trying to do the right thing.
One common theme, I think, that came through was the need for what I call big data. So platforms, the data itself, analytic tools. So how do you each see that, that improving the different approaches, getting to more data so that it can be, so that these findings can be accessible? Because the understanding of all the different hundreds of genes didn't happen through 500 individuals. It happened through hundreds of thousands of individuals. And the same thing with the subtyping methods.
I agree. I mean, the power of big data is it's been an amazing revelation, at least during my research career, going from small studies of 20, 30, 100 people and realizing the clarity with which you can gain by adding the larger numbers. You get rid of a lot of noise. All of a sudden, things that you think might be scary actually go away. So I think it's critical that we achieve those larger sample sizes through registry systems or other kinds of data mechanisms that improve our numbers. Autism is pretty rare basically, it's still a relatively rare condition. So when you combine a rare condition with a particular rare exposure or a co-occurring condition, that becomes even smaller group. And so in order to get reliable and valid results, you need big numbers. And that's what we're trying to search for, the opportunities for gathering those big numbers so that our information about autism becomes more reliable and more valid.
I would agree with everything you just said, and I would amplify it on three fronts. One is the ability to do unbiased genomics, I think, cannot be overstated. So, as opposed to doing very expensive gene by gene or gene panels or something, the ability now really to look at the whole genome, no longer even just the whole exome, the whole genome for hundreds of dollars is pretty extraordinary. On the phenotyping front, I'm particularly excited by the technology advances that are allowing us to collect data that are closer to biology, like things we run on our wrists or iPhones. But I'll just give one example that my colleagues who are in the room will know I talk about all the time, is the ability, for example, to do home EEG over extended period of time with a relatively inexpensive thing that you can wear and go to sleep with and get actually reasonable quality sleep EEG. And so I think that it cannot be understated. And then the analysis techniques that we're all hearing about and getting more familiar with, the things having to do with artificial intelligence and machine learning, are transforming our ability to comb through this massive data that would otherwise be impenetrable. So I think those three fronts are really exciting.
I'll just add that I think the true benefit of these big data approaches is when you really don't know the answer. And when you start thinking about what we know about the sort of full biology and therapy of autism, we just need to confront our ignorance. And that's where a big data approach goes. We saw this in the genetics. While some people guessed the synaptic component, I don't think anyone really guessed the idea that the the way that genes are transcribed would be the biggest signal that we saw. That was really a surprise which came out. And so trying to embrace that ignorance through a multiple parallel approach as we get in big data. The other pieces which big data does well is interactions. So we've done very well at additive effects, but trying to think about how different bits of the data interact, like socioeconomic and genetics or subtypes of biology. For that, you need massive, massive data sets, much more than, say, for an additive effect.
And I'll ask one more question, and then we'll take some from the audience, which is, in 5 to 10 years, what do you think the major discoveries are going to be around epidemiology, or what do you hope we look at in 5 to 10 years, or we know? You don't have to say what we know, but the sort of things we know in understanding different subtypes as well as genes, and looking at epidemiological approaches and gene-environment interactions.
Throughout the time I've been doing autism research, which is too many years now that I want to count, I have been impressed with as we become more knowledgeable, we apply more rigorous data, more rigorous analyses, how many of those early risk factors are going away. So I think the epidemiologic profile of autism is still in flux. I still think we have a lot to learn, but I think we can recognize now that many of the things that we thought were particularly hazardous, they're going to go away. They're not going away because the risk is going away. Our understanding of the association is being better addressed. So I think the big data, the advance in the analytic tools that we have are whittling away at that epidemiologic framework, which we thought, oh, we'll answer this next week, and it's not true. It's not. It's taking a lot longer. And so I think we'll be a lot more wise about where the opportunities for intervention, where the opportunities for modification in the life course of a person with autism. And I think we also need to stretch into the life course. We're still too focused on the first perinatal period. I think we need to get into the life course to better understand the connection between, the child being born and what's happening 50 years later. That's the epidemiology that remains to be investigated.
Yeah, I suppose, the dream would be that from a very early age, we would be using tools that would help augment a clinician's, analysis of a child's development. And I agree about this life course thing, and that we would be able to make a diagnosis that really means something in terms of having some predictive value about interventions or trajectory that really means something for the family. And maybe it's overly optimistic, but I have a sense that if we were to achieve some of those goals, some of the controversy in the field about the use of language and stuff might sort of melt away a little bit, because the diagnosis would have more specific meaning. Maybe it would even, I sort of hinted at it in my talk, but maybe some of the words that we use would be replaced by different kinds of categories that had more predictive value.
And I hope that in 10 years, that genetic medicines would be a routine part of care, taking place in a nationalized social healthcare system.
I think that.
The real optimist. The real optimist.
Okay, so we do have time. If anyone has any questions for all three panelists, or individual questions, anything you want to follow up on?
Hi, thank you all so much. My name is Morgan Firestein, Assistant Professor at Rutgers University. I'm curious, there are many tools that are used by clinicians to diagnose individuals with autism that differ in their use and application from those used by researchers to establish behavioral phenotypes. The ICD-10 codes are often used and interpreted very differently between clinicians and researchers. The ADOS is administered differently for research purposes versus clinical. I'm curious whether any of the panelists think that this may be contributing to the heterogeneity that we see in research, whether this is hindering our ability to leverage existing clinical data with research data, and if there are any recommendations for how we may be able to better harmonize those data.
I can take a shot at that. I should say at the outfront, I hope people know I'm not a clinician, but I will take a shot at it because we had a workshop at the Simons Foundation recently where we talked about the potential of integrating some new technologies into more clinical settings. And just to give you like a very simple example, and there are some groups around the world that are starting to do this, where you would do videotaping during an ADOS, for example, and use machine learning and computer vision to sort of derive measures that the clinician may be trying to do intuitively, but basically as an additional tool that a clinician could use that would break down the behavior about things like eye movements and motor stereotypies and things like that. So I see that as like a potential, should that technology, which is, I think that's not science fiction to think about that emerging in the next couple of years. I think that might be one such example.
I would absolutely agree. I think if we think about the example of heart disease, which you gave earlier, the improvements in subtyping came from orthogonal metrics like EKGs or eventually molecular markers. I think we need to see the existing diagnoses augmented by other ones found by basic research.
I think I just want to throw back again my push for the life course approach, the life course perspective, because I think the phenotypes, the characteristics of individuals in the early life, how do those evolve across time and across age, which may give us actually, those may be subtypes we also may need to pay attention to. So we need to get a longer perspective, and now that the autism research is developing, we have those longitudinal data, and so I think using those long-term outcomes to accompany the early childhood outcomes may actually clarify some of this heterogeneity we're trying to tackle.
Thank you. I was really struck by the kind of universal mention of the need for stakeholder input in these talks, especially given as several people have observed, how contested and divided the autism community is. I was particularly struck by Dr. Spiro's, your statement that you think that subtyping autism is uncontroversial, because I assure you it is not, and there is a very vocal set of stakeholders that are very resistant to breaking up the spectrum, and I am a historian of medicine, and so I find that to be a peculiar stance because, as we all know, autism has been a very unstable diagnosis over time, so why we have like the particular affiliation for how it is at this moment is perplexing to me. But anyway, I would just ask, is stakeholder involvement always necessary in advancing scientific questions? And if so, in autism, how do you resolve these extremely different priorities and philosophies that you have to kind of, if you want to bring stakeholders in the autism community together?
I'll let someone else further, but I'm just going to start by saying I didn't say that it was uncontroversial. I said that I think it should be somewhat uncontroversial. So I'm, of course, incredibly aware of the controversies and, often around identity, I think, which is what adds complexity to this. Just so I'm very well aware of that. What I meant was that, given the changing diagnosis over time and the insights that we're getting into the biology, so the example of the papers that I talked about, for example, that draw distinctions between, that's why I think they're so powerful, between the genetic makeup, for even just taking the simplest example, for example, of early and late diagnosis, that I think from a strictly scientific standpoint, it should be relatively uncontroversial that we're talking about a very, very broad biological spectrum that may not hang together. Historically, of course, it started because there was the sense that it did describe something that brought together disparate things. But so that's as far as I wanted to take it, not that there's no controversy.
I think that there's obviously a limit to the amount of detail in terms of stakeholder engagement. As in, when you start getting deeply into the weeds of how a single gene works, you're probably getting to the stage where unless that person has a personal relationship with that gene, you're going too far. But I think in terms of shaping the overall questions you ask, it's critical. In my own work, we identified the role of the gene SCN2A in 2012 in autism and started working with the family group when they were set up. And we would go there again and again and show, here's this beautiful piece of neuroscience we've done. We understand this little bit more about which neuron it's working on, which different piece. And the question at the end of every talk was, that's great, when's the therapy? And eventually you start listening and thinking, okay, well, I'll go and start working on therapies as well. And so I think that it's that broad level of trying to guide the nature of your quest where I think it's particularly critical to have the temperature of the field.
I just want to add, I agree with you, but my experience working with the community advisory board that's attached to one of my research projects, it's forced me, in order to get meaningful dialogue going with my community advisory board, it's not that I'm going, so what should I be studying? It's framing the question, this is where I want to go, help me, how do I get there? And actually framing it, it's forcing me out of my own comfort zone, out of my sort of science framework into the community framework, and asking the right question to get an answer. And then the answers that come back are revelational. And it's like, oh, okay, that's how I think about this. But the initial question was pushing me out of my comfort zone. And that forces me, in order to interact effectively with my community advisory board, to get out of that comfort zone. And I think that's been extraordinarily beneficial in eliciting the information that I can take back then and translate into a scientific study. And without that integration, my study, my work is diminished. It's still productive, but it loses that savor of real in-depth understanding of what the questions are.
Well, I think we have one more question.
This is going to be the last question.
Okay.
My name's Carl Wittig, and I'd like to make some comments about what we've heard today, because I'm in the position of being an adult on the autism spectrum and coming from a scientific background. And even though my background has nothing to do with autism science, well, physics and electrical engineering to be precise, and I worked in a research laboratory environment for nearly 30 years, I think all of this puts me in a position to especially appreciate the value of science in general and autism science in particular. And I just wanted to address some of the areas we heard today. First of all, as far as genetics is concerned, in spite of the tremendous amount of work that's been done, not to mention the incredible growth of both genome sequencing and AI and machine intelligence and data science, all of which have grown exponentially over the past few decades. And we're still at only 10 to 20%. We haven't even come close to cracking it. What that tells us is we don't need less science, we need a lot more science here. Now, secondly, in the area of neuroscience and neurobiology, here we're in a situation where we're literally talking about the human brain and the human mind being the two entities in the entire universe that are least understood. I mean, forget about the origin of the universe and dark matter and dark energy, which you've heard about. Those are all very well understood compared to where we are with the human brain and the human mind. So here we need a hell of a lot more science. And finally, and this one is of the greatest personal significance to me in the area of autism subtypes, because my own diagnosis 25 years ago at the age of 44 only happened because of the expansion of diagnostic criteria to various subtypes with DSM-4 in 1994, and which is why I was able to finally, as an older adult, figured out that I'd been living with a form of autism my entire life, and neither I nor anyone else knew it. So, okay, I'd finally like to say that as far as profound autism and the more severe forms, I obviously am not in any position to speak to them, so I'm not going to. But as far as, in my own case, level 1 ASD, formerly Asperger's syndrome, that even though our challenges are far less serious, the fact is there are many more of us. We're talking literally several million people in the US alone, the vast majority of whom, and including virtually all of whom past a certain age, were never identified or diagnosed. But for such individuals, it's well known that in many, if not most cases, it is possible for many of us to pursue education, find employment, and live independently, which means that, in every one of those cases, you would have somebody who does not need any resources, and if anything, can contribute as a taxpayer, thereby freeing up those resources for the people who really need it no matter what. Thank you.
You had me at more science, not less science. So I think that's a good way to end up this panel. So thank you all again for participating in the panel, and thank you for being at the Day of Learning.